Hi, it's Dave. What follows is my conversation with Anatoly Yakovenko. He is the co-founder of the Solana protocol, which claims to solve the biggest problems facing blockchains like Bitcoin, Ethereum, Cardano, and others. Rather than proof of work or proof of stake, Solana is pursuing what is called proof of history. And at the time of this recording, Solana's SOL token has a market cap of $10 billion dollars and is attracting a lot of attention from those saying it might be the Ethereum killer. I spent the last couple of weeks watching dozens of videos about Solana and had a ton of questions I wanted answered myself. At the core, I'm looking to understand the essence of Solana and if it can really live up to its potential in a crowded crypto space. The first 10 minutes or so of the conversation, my mic was actually turned off. So I've edited out those questions and replaced them with some text slides. I hope you enjoy the conversation.
There's basically two problems that are interesting in these systems. This idea of proof of work, it's an availability system. It never actually guarantees consistency. It never guarantees that the entire chain is fully committed and never going to go away. What it does guarantee, though, is when you have your Bitcoin and you observe blocks building on top of it, you can calculate how much thermodynamic energy has been spent to secure your Bitcoin, right? You can say, okay, even though this chain is not never going to guarantee that I actually have my Bitcoin, but this $100 million or $200 million or billions and billions upon dollars of electricity guarantee that it's going to take at least that much to take it away from me, right? And that accumulation of that security is a property that is unique to proof of work. At the same time, it's weak it's actually pretty weak at guaranteeing censorship resistance in the same sense that you and me are able to communicate in a peer-to-peer fashion with everybody in the world instantly. Like that instantaneous communication, that like the end general's problem in the moment, if you want to think about it, proof of work is really, really bad at that because you can revert short forks, right? And the way hash power and mining concentrates in a very few set of block producers. There's maybe 5 block producers that add up to 51%. Now, you as a Bitcoin holder, you don't really care about that because every block they produce just makes more your crypto that you're not spending or just storing, in case something goes wrong. It just makes it even more secure. So there's this kind of that side of it, I think, is very well optimized for store of value, but absolutely broken for finance. And finance depends on actually censorship resistance or this ability for information to flow with extremely high reliability in the moment, like right now. One way that I kind of describe it is, you know, these big concrete buildings in Manhattan that stock exchange, they literally have mainframe computers that have CPUs that replicate the exact same instruction. There's an array of these CPUs, and if one has an error, they can hot swap them, right? So they can replace the broken CPU and put a new one in without interrupting the markets because it's so important that it never happens. That piece is fault tolerance, and that's kind of like hard engineering fault tolerance problems. But if I want to trade in that system and I go through all the hoops to get my servers there, they will cut me a cable that's exactly the same length as everyone else's cable to guarantee that my information has fair and open access to these markets amongst all the other participants, that nobody's really getting ahead of anyone else. And that bit is the censorship resistant piece. Right now, like Bitcoin is guaranteeing fault tolerance to a very extremely high degree for like kind of storing your Bitcoin. Fault tolerance isn't quite the right way to correct it, but it's not really guaranteeing that when I submit my transaction, that it's going to be included in like 2 seconds, right? Like neither is Ethereum, um, because there's so much congestion and so much demand, and so few miners control the access to that network that those guarantees are not really applied. There's market forces that allow some participants access, but it's not the same as every market maker in the world, every trader in the world can go take a trade and put it in the system. Um, and this is where Solana shines. How do we maximize the minimum set of entities that could potentially disrupt the flow of information, right? The larger set, the bigger that set gets, the harder it is for all of them to coordinate to do so, the more secure the network is from that information flow perspective, and therefore systems that are running inside of it that are fundamentally markets become fair and more open. And long-term goal for us is, I like people ask me, are we an Ethereum killer? I've never thought of Ethereum as something to be killed. It's an awesome open source project. Our seed level slide said Solana's blockchain and Nasdaq speed, right? They didn't say Ethereum 2.0. We're targeting more like, bigger dragons there, right? Like
Hmm.
we want this like foundational, fundamental engine of finance, which is global price discovery. We want that to be fair and open, running on open software, open hardware run by volunteers
Hmm.
effectively, all around the world.
Hmm.
So that's the fundamental difference between, I think, store of value and proof of work. Um, if you're optimizing for that, and I think what we're doing, which is censorship resistance, like of information flow.
Got it.
How can we guarantee that any two parties in the world in any moment are guaranteed that they can send a financial message to each other at a fair and open network?
Okay, so let me kind of summarize. Correct me if I'm wrong here. So with proof of work, right now that's the best we have in terms of kind of store value because it basically pulls together all of the energy that was required to secure that network, which is extremely expensive. Um, and you guys on the other side are not necessarily solving the store value problem, but you're solving a different problem, which is the whole information flow, the flow of information at very fast speeds, also low cost, to create, I guess, market dynamics like on the blockchain in a true sense. I mean, can you explain kind of what's been holding back crypto? I mean, because we have, the promise of DeFi, of crypto to provide that info flow, but it seems like there's lots of gas fees, lots of, different problems. What's been kind of like the Achilles heel or the issue kind of behind all
So
this?
I think projects that came out of Bitcoin, like Ethereum, they're kind of carrying their baggage with them still. They're thinking about store value, self-sovereign money. That is like an important use case, and they don't want to give it up. So I think ironically is they're trying to build these other things that I think much more interesting, but they want to keep that piece, which is impossible to do without just being Bitcoin. So this is where I think like the value that you're adding is removing so much of the original vision of Bitcoin that you're kind of creating a worse overall kind of product or combination of the numbers you're the all these factors are Pareto efficient, right? The trade-offs you're making, I think, end up not being Pareto efficient. Um, on the censorship resistance piece, the this is from the ground up, ignoring everything about what people think of proof of work and what people think of enterprise blockchain. Like it has none of those things in it. It's really like, what if we had a global price discovery engine? What if you could have this machine, right, that's fully connected, single sharded, there's no compromises on the communication aspect of it, that guaranteed that any two peers that are using it around the world have effectively a fully connected system that, like censorship resistance and general's problem, if you have a solution for that, then all the users that are using that black box, you can consider them fully connected. They're not no longer using an intermediary that can disrupt the information flow from any connection. And if you have that at a global scale and this thing is running markets and doing price discovery, then you've effectively kind of, I think, unleashed this like idea of true peer-to-peer financial systems that are totally running in software without any intermediaries on the world. I think that's really disruptive and kind of a really just, why not? Like,
Hmm.
and really cool to think about. at the at like the physics level, people often ask us like, well, Nasdaq has like sub 1 millisecond trades. How you ever compete with that? Reality is that news, like information around the world, travels at speed of light through fiber. Like it still has to go through speed of light through fiber. Some event happens in Moscow and Hong Kong, then information travels speed of light through fiber to a terminal in Bloomberg that a trader looks at. Well, at the same time, a state transition through Solana, right, can be inserted at Moscow and propagate through the network through Solana, right, for that market. So when the trader actually looks at a price at the New York Stock Exchange and a price on a market like Serum running on our information network effectively,
Mhm.
that price is already reflected. That for all the important newsworthy trades, you can have instantaneous global clearing and settlement, like execution and clearing, and then some settlement layer can do that later. Um, so that's pretty fundamentally different than these centralized systems where
Mhm.
you have to jump through a bunch of hoops to get your connection, to get a box in, and then somebody that pays more has a higher priority than you.
Mhm.
I think that could really, in my mind, transform finance. We could be, 10 years from now, we could be living in a world where 100 million people put in 1 cent into, your house purchase in San Francisco.
Um, so there's I want to get into the specific technicals behind proof of
Yeah,
history and why Solana or how Solana works. But before that, I want to give some context here. So I was kind of looking into what Solana, how many transactions you guys are doing right now. Looks like you guys are doing like between 500 and 1,000 transactions per second. But this is like real. These are real transactions, right? These are not just test transactions. This is like
yes,
real world
yeah. So
activity, right? Happening
just
right now, right?
yes, so 20 million a day serum. About half of those transactions are consensus messages themselves. So it's just nodes using the network themselves to synchronize.
Mhm.
We have a different design from a lot of networks because we're optimizing for that core censorship resistance piece, where nodes that are participating in consensus, their votes are themselves signed messages that pay a fee that have to pay a transaction fee like everything else because they are competing for the same information resources as Serum markets. That it's not like a system where you have one platform and then that allows other applications to run. It is like the shared pipe for everything. So about half of those, about 50%, are consensus messages. So I wouldn't want to count those as user data. Um, about the other 40% are Serum. Like this is a central limit order book built by the folks out of FTX initially. Now it's its own community and like community run project. Um, it operates just like a central limit order book does on Nasdaq or on Binance or on FTX. So there's a bunch of market makers that are constantly submitting orders, cancels, um, and that thing does two, 300 times more transaction messages than Uniswap, but that doesn't mean that there's that many more users, right? Like it's just Uniswap is a different kind of financial system that is constant function market makers. They're super cool design, but it's not the same as like a market maker driven central limit order book. But that is real businesses, real market makers, real traders trading on this thing. So that's real activity.
Um, it's yeah, it's definitely fascinating. So I mean, Serum, for those who don't know, it's basically an exchange, right? You could basically buy different currencies, exchange them, and they're running on top of Solana right now. They chose you guys mainly because of these characteristics where you could have an
Yep.
immense amount of output or throughput transactions per second, but they're extremely inexpensive each transaction. Can you give us an idea of like how much each transaction costs? I mean, I guess it varies according to the amount, right, of each transaction or the value of transaction.
It's not value based, so it is it's more the token, right? The sole token is there to prevent spam on the network. Part of that, part of what could be causing spam is CPU time, right? Data, like storage, etc. Um, so our target for the cost to use the network based on current global bandwidth prices is about $10 for a million messages. So So that's, I think, 10,000 times cheaper than Ethereum. Or I mean, it depends which Ethereum you're looking. The way I think of Ethereum when it was still 10 cents a transaction. Now that it's $100 per transaction in Ethereum, it's 10 million times cheaper than Ethereum is today.
Hmm.
Uh, but again, who we set our sights on was Nasdaq,
Yeah,
which I believe their message rates are like 0.15, something like that.
got it. Um, so I mean, you guys got this, you got your working protocol up, you've got, it tested out, you have real life transactions, 500 to 1,000 transactions per second happening right now on the Solana blockchain. This is not just theoretical. We're going to release this in 2 or 3 years.
Yeah.
Um, what's like? What are the limitations? I mean, can you guys do you have smart contracts? The ability to put smart
Yeah.
contracts on your blockchain, and is it any different
Yeah.
than Ethereum and their approach?
Yeah, it's quite different. EVM is like one of another thing that I feel like is holding back the industry. EVM is a really kind of slow sequential virtual machine that's stack based, that's got these massive 256-bit values. It wasn't designed for speed in any way.
For those who
And it has
don't,
this,
for those watching who don't know, EVM is the Ethereum virtual machine that basically runs the Ethereum network. Go ahead.
it's, yeah, it wasn't built by folks that have been like optimizing virtual machines for a decade. uh, so uh, we are using Berkeley Packet Filter, which is a virtual machine built by the Linux kernel community. It's designed to execute inside the Linux kernel. So it has the highest security requirements out of any VM out there, but also the highest performance requirements because it's used for network switch operation. So BPF on its own has been demonstrated to do 60 million packets per second inside the Linux kernel. So it kind of has these really nice uh, optimizations that make it really easy to optimize it on modern day hardware. So this is why we chose BPF as our target virtual machine. So the way that you use it is Solidity in Ethereum has this implementation that's also the standard, kind of one vertically integrated thing where Solidity compiler spits out EVM bytecode that's executed on the EVM virtual machine. Uh, BPF, because it's a standardized language, has LLVM as its compiler, which is a standard compiler used by Apple, Intel, NVIDIA, Qualcomm, you name it, to compile any number of front-end languages. Right now, we are primarily focusing on Rust as our smart contract language. And it's kind of, if you're familiar with Java, C++, you should be able to pick it up in a week. It's a modern version of this, so it has a lot of advancements in type theory have been adopted in Rust. It was built initially by the Mozilla team, but is now, I think it's been voted number one as the most favorite language by GitHub engineers. I think it's in the top 10 or top 15 in terms of popularity on GitHub as a language. Most modern blockchains themselves are built in Rust, which is interesting. It's being proposed as a language for the Linux kernel, which is kind of mind blowing to me because I worked in the Linux kernel and it's all C, and Linus has been like so adamant about rejecting C++, but I believe he sees in Rust what I see in Rust, which is a really nice, clean implementation of a modern type system on top of a language that is really optimized for hardware.
Awesome. So in terms of smart contracts, I mean, if you guys can do smart contracts, you guys are proving your throughput and your transactions. Um, why is there a need for Ethereum 2.0? Like, what's the point?
So the philosophy of like Ethereum is still kind of, I believe, straddling both of those worlds, right? One is, I think we're primarily focused on information flow. How do we build this super connected world, right? How do we simulate censorship resistance to the level that you can't differentiate that from, super, if everybody in the world had like neutrino lasers that we could unobstructedly use to talk to each other, right? That's like the physical network that we're trying to build. Um, Ethereum is really focused on this idea that you can replace proof of work or self-sovereign money or store value with proof of stake systems with a massive number of them that all verify each other. It's interesting. Like I don't know if they'll succeed, but you know it's worth trying. This is what they believe, right? Like it's an open source project, open source community. Um, because the space, like the trade-offs are Pareto efficient. You can't do one or the other. There's absolutely zero chance that central limit order books are going to run on Ethereum, ETH1 or ETH2. Like that kind of scaling, they're just not doing. Um, I kind of I suspect that if we succeed in our goal of really truly building this massively censorship resistant system such that it takes 10,000 independent parties to collude to disrupt the flow of information. Um, I think the properties of store of value will emerge there as well, because I believe that the proof of work piece isn't necessarily as important as the number of people involved with cryptographic keys that are all signing the same kind of state. Like the real security, is the people at the end of the day, right? We can all reject proof of work and switch to something else, right? That Bitcoin state machine could be running on Solana, and if if it's 1,000 people, it may not be worth something. But if it's 100 million, if it's a billion, then all of a sudden the same properties that you see at a proof of work will start to emerge just from this idea that a billion people can coordinate over the exact same state. Um, and but that's we'll see if that happens. That's kind of a unknown still.
Hmm. Got it. I mean, from what I'm hearing, you're saying that, with Ethereum 2.0, they're still trying to they're trying to do both, the best of both worlds in their view, trying to
Yeah.
solve the store of value problem, as well as trying to improve their whole, transaction information flow problem. But in your view, they're compromising on both, basically.
Yeah.
Um,
Yeah.
they might not be as good as Bitcoin in terms of store of value, and they're obviously not as good as, for example, some other projects like Solana on throughput and information flow. Um, how about
So
Lightning?
there is no other
Okay.
project that is actually like really committed to this idea of maximizing censorship resistance.
Huh.
There's not one. I honestly feel that we came out at this with a really like in the unique quadrant. Like,
Uh,
how do we solve this problem and only this problem as the fundamental thing that we're working on?
okay. Okay. I want to ask about this. So maximizing censorship resistance. So, um, like, what does that mean exactly? I mean, because all blockchains and crypto will say, "Hey, this is decentralized, secure."
Okay.
So meaning like things flow. But in terms of how are why do you say that
So,
you guys are
so
the only
security, so
prop?
security comes from cryptography,
Mhm.
right? In any properly implemented layer one, if I if my keys are not leaked, nobody can steal my funds, right? That's impossible, right? Let's say I have some keys that represent USDC. So Circle is the thing that's providing custody for the dollars in a bank, and I have digital representation of those with my keys that I hold. The intermediate network, if it's 100% corrupted between me and Circle, no matter what they do, they cannot steal my keys because there's no way they can convince Circle that I signed a message that says spent Anatoly's dollars. So the fundamental security of value is my keys, right, between me as a peer and Circle. Um, so all of these layer ones, unless they screw something up horribly,
Mhm.
should be secure.
Mhm.
Then the question is, can they guarantee liveness or consistency, right? Can they guarantee both of those properties to a very high degree? Um, and that's the hard part. So the challenge for censorship resistance is that it's really hard. Like it's really hard to guarantee that you have the performance necessary to handle that a very large set of nodes that could potentially disrupt the flow of information because that set has to be super connected. They have to process all of each other's messages. If they don't, then there's a smaller set that can do it, right? So there's that minimum set, maximizing it means maximizing the amount of data messages, cryptographic signatures that all the participants in the network have to read and write. And that is kind of a problem of hardware optimizations. How do I like, you know, how do I go and like take this cryptographic operations, move them to GPUs? How do I move them to CPUs, to, single SIMD, AVX, whatever have you? How do I minimize the amount of time it takes to read packets from network cards into the kernel, right? Like, it's not computer science. It's just kind of blood, sweat, and tears engineering.
Hmm.
So like doing that is just hard. Imagine, right? Like USDC, USDT, those are the top traded base pairs on exchanges, or right? And the value of who owns USDT, or that information, who owns USDT and USDC, is traveling across between exchanges. Um, if the only network that that information can travel through, let's say, is Ethereum, and it takes 5 mining pools, actually 3 mining pools, to hit up to 51%, then those mining pools decide whose dollars get to travel from Coinbase to Binance to FTX first, right? So they get to prioritize which financial institution gets to take advantage of any market opportunity in any of these marketplaces. So just three entities,
Huh. Uh-huh.
right? They get to pick, right? And right now, because crypto, I think, is still quite immature, um, it's not a huge problem. But we start seeing that being a problem in like things like miner extracting value and flashbots and things like that that are looking at trades and mempool and get to prioritize which trades or which blocks, and how me as a miner, how can I take advantage of that information, right? That when I'm constructing the block, and extract the value from the users and from the network. Um, so that bit, like that amount of information and value that any of these block producers can extract, it really depends on what is the smallest set, right, that control the network, that have the opportunities to do so. If we maximize that set to 10,000, right, or some large enough number, then it's effectively an open fair marketplace, because information can be basically can flow freely, because it takes so many of them to really collude to disrupt its flow.
Got it. I mean, so you're saying that with Ethereum or some other chains, like if the mining pools are more consolidated, you have big players that inherently, I guess, allows for more censorship or more opportunity for them to take advantage of that extra
So
information that they have at the
right.
moment.
But fundamentally, that's a different form of censorship than
Hmm.
I have my Bitcoin. There may be 5 mining pools today that won't let me spend it, but 5 years from now, there's going to be another set of mining pools that may, right? That Bitcoin guarantees this that eventually somebody will accept your Bitcoin, because your Bitcoin is safe and secure. But because it's safe, and the guarantee that it's safe and secure from reversal of this fork, right? Of like somebody replacing the current ledger of Bitcoin with something else. Um, and that's what gives this kind of, loop of self-sovereign money, right? It's its own money. It's hard to buy it, right? Because we're not talking it's hard to analyze, and hard to accept it as a truth, because it's it's not the same as like understanding dollars between exchanges moving, by hedge funds, right?
Hmm.
That's like almost like a simple software problem. How do we guarantee that this is a fair market? Well, SEC and like a bunch of financial regulation in the United States guarantees it at the physical level, right? Between all of these like exchanges and financial institutions. There's enough regulation that they can't, screw each other.
Hmm.
But how do we do it in an open environment around the world, right? Open price discovery engine where anybody can participate.
Hmm.
Um, there's no global set of regulators that say you can't do this, and that would be impossible to enforce anyways,
Hmm.
right? So, and we have the opportunity to do this with commodity hardware and software. So that's, I think, both the challenge and the opportunity here.
Uh, Interesting. I mean, with Bitcoin, would you, in terms of censorship resistance, would you say that it's that they have censorship resistance. It's just more limited. It's not maximized in terms of information flow, but at least it's there with,
It's
or it's
it's
not.
uh it's different.
Mm,
The idea that if you have Bitcoin and you try to spend it, that eventually some honest block producer will pick it up and spend it, right? It's that given unlimited amount of time, Bitcoin can provide extremely high degree of censorship resistance, but
mm.
it doesn't guarantee immediate information flow.
Got it. Yeah. So in terms of maximizing, especially with information flow, there's major limitations. Um, I'm wondering, what do you think about Lightning? I mean, some people are saying, hey, the second layer solution, Bitcoin will transform Bitcoin into this payment network. Maybe it solves the information flow problem. I mean, what are your thoughts with that?
I don't, does anybody need payments for Bitcoin? I feel like if payments was such a really killer use case for Bitcoin, then there would be Square app and mobile that was in between, like was good enough in terms of security that would let us send, wrap BTC and Solana to each other. Is that something that Bitcoin even needs or care or anybody that's using Bitcoin even cares about it?
Hmm.
There's some small percentage of people, right, that are all working on it, but I think it's not like a burning fire of a problem for Bitcoin. I think Bitcoin is functioning as a kind of this like settlement layer between exchanges. That's an interesting use case.
Yeah. I mean, what's your take on the future of payments? I mean, does crypto, do you think, play a role where we're going to be, transferring just tips and different, money back and
Totally.
forth across, you know, different to different people across different geographies, or do you think, um, and like, do you think it's just going to be for a blockchain that's meant for that, that's designed, for payments?
There's nothing that you would design differently about that blockchain than already doesn't exist on Solana. Like in terms of the hardest problem, how do you make them is censorship resistance at scale? Because the network has to be massively decentralized and has to be insanely high performant to handle market makers like that are sending, 300 more cancel messages per trade for a single trade. So in terms of kind of performance and loads, Nasdaq style like real time trading is a much harder problem. Um, I think payments is it's also like this was like the story of 2018, 2017. Is payments going to be big?
Yeah.
Possibly. Like I think the interesting part there isn't the peer to peer send you dollars. You can do that with Venmo already. Um, what's interesting to me about it is how rapidly teams can innovate and custom design products and kind of bespoke solutions for smaller networks, for like merchants, for like smaller